Thank you, Gun, for joining me on the podcast today. I really appreciate you taking the time. You are the founder and CEO of Ava Labs, building Avalanche, one of the leading layer one blockchains. The associated cryptocurrency AVAX has got a $13 billion market cap as of this recording, and a lot of people became aware of your work. Last cycle in 2021 or so, towards the early days of what you were building. Last hype cycle, Avalanche kind of came on the map along with some other sort of newer projects within the crypto landscape beyond just Bitcoin and Ethereum. And it's exciting now, a cycle later, to see everything's still going and very strong, and just excited to see where it all goes this next cycle. So appreciate you taking the time. For those who aren't familiar with you or your work, I think the best place to start would be if you could just kind of tell your story, whatever version, whatever length you like. But one thing I think is always interesting is just to hear, the earlier you're willing to start, sort of hear about some of those early decisions and, things that got you to where you are today.
Sure. Thanks for having me, Jake. Let me try to do this quickly if I can. I've been around. I'm one of the people who've been around this space the longest, and it goes back. My story goes back a long ways to 2002. So I used to, for 19 years, I was a professor of computer science at Cornell University, and my expertise area is still operating systems and distributed systems. And back in 2002, I was a freshly minted young professor, and I really, really liked file sharing systems, and they were like the hot item back then. And as with any large system, any complex system, these systems suffered from a common problem known as tragedy of the commons. People wanted to take resources, they wanted to download. Nobody wanted to upload. Nobody wanted to give up their upload bandwidth to the collective good. This is a very common problem. And I was drawn to complex systems. I was drawn to issues of incentives and game theory. And, and the solution seemed obvious to me at the time, which is, look, these people, they just want to take things. So you gotta invent something, a limited capped commodity that they should use to pay for things so that you can limit their bad behavior. You give everybody an initial purse, they can buy things with it, but at some point they will run out, and at that point they will be forced to sell things to get more money so they can continue to consume. So I wanted to build a virtual economy. And given the nature of file sharing systems, you can't be in a central bank position. You can't have a centralized system for this. So I came up with a system known as Karma in 2002. It was published in 2003, and Karma was an internet currency without a central bank. It was issued by proof of work. So it was the first currency that I'm aware of that incorporated this idea of solving a puzzle, very similar to the Bitcoin puzzle, actually, it turns out, at the crypto level. So solving a puzzle in order to get the coins that you want to get. So that was 6 years before the Bitcoin white paper. And so anyhow, Karma is very well cited. Academics know about it very well. It's incredibly well cited, actually. So that's the work I did back then. So then when Bitcoin came along, it brought in one additional big step improvement on top of Karma that I hadn't thought of. So Satoshi is brilliant. He came up not only with the minting idea that we have in Karma, but he also rolled in the consensus protocol into the minting process. So he greatly simplified the system that he had to build, and Bitcoin was a big success. My second project then was to investigate Satoshi's claims about Bitcoin, and I came up with working with a postdoc at Cornell at the time, Itai Eyal, who's currently a professor in Israel. Itai and I came up with something called selfish mining, which is the biggest known flaw in Bitcoin. And essentially, if you follow not what Satoshi told you to do, but what we outlined in that paper, a miner can make more money than their fair share. So so we got a lot of pushback from the Bitcoin community, which at the time thought Satoshi was infallible. He couldn't possibly make any mistakes. And so we were saying, look, some of his claims are incorrect. And so they first of all, I got death threats. Then came the projects that the Bitcoin community funded to prove us wrong, and then all of those projects flipped because ultimately they tried to prove us wrong and decided and ended up proving that we were indeed right. And so, ultimately the Bitcoin community realized that we were here to try to make Bitcoin stronger, to characterize its security better, and the entire system is stronger as a result of our work. And so anyway, so then after that, I did a lot of work on all aspects of blockchains. I worked on fast layer twos. I worked on characterizing decentralization. I worked on measuring scalability of blockchains. And most recently, I worked on building the world's fastest, most scalable, most versatile blockchain. And I decided that what we came up with was so good that I couldn't just punt it into the ether, so to speak, punt it into the air and let other people run with it, because I feared that they would mess it up. And I thought, this is such a big breakthrough that I need to make sure that it's handled well, it's built well, that the execution of this idea does justice to its fundamental nature. So I started Ava Labs to build a new blockchain platform, and thus came Avalanche. So that's my short story, and it's been a fun ride. I've been in this space longer than most anyone, and I've had a hand in every layer of the software stack.
Yeah, no, I appreciate you giving the background, and certainly launching the first coin system based on proof of work back in 2002 is like a crazy thing to hear that, obviously most, people are familiar with Bitcoin, and it's like, okay, 2009, 2010, you
Yep.
sort of wrap your head around that being a pretty long time ago, given crypto still feels quite early to a lot of people.
Yep.
And then you go back another 5, 6 years or whatever it was, and it's you realize that people were thinking about problems in related spaces for a long time before Bitcoin came along and Bitcoin kind of broke through.
Right.
But people have been interested in these spaces for a long time. So sort
Yeah.
of,
Yeah.
to that
There's
point, well, go
Hey,
ahead.
Jake, let me add a little bit more, just so people don't think that I'm claiming all the credit for myself. There's work that predates me on virtual currencies. There was work on microcurrencies in the mid 1990s. There was a system called Millicent. There were a couple of other systems, and they all suffered from having some kind of a responsible party. And if there is a responsible party, then the system can be killed. So Karma did not have that, and Bitcoin does not have that. And Bitcoin actually has that beautiful, elegant consensus protocol rolled into it. So yeah, there has been a great progression. But yes, there were people who paved the foundation of this area way before Satoshi came along.
So was the global like group of people interested in this space somewhat, collected through the internet? Obviously it was decentralized globally, but was everyone kind of aware of what everyone was working on, or when Bitcoin came out, did it take you some time to actually come across it?
Oh, Bitcoin completely took everybody by surprise. Let's just put that out there. And the academics and the folks who were working on microcurrencies, people like me who were working on peer-to-peer currencies, they were doing things in their separate silos. And the systems that were invented in the 1990s, the idea was typically they were motivated by the desire to pay for things on the internet in a simple, flawless, sort of like a low overhead fashion. So credit card payments were expensive, especially at the time. And if you're going to pay a few cents, you don't want to use your credit card for a 1 cent or a 2 cent payment.
Right.
So it's just not cost effective. So that was the problem that they were trying to solve in the 90s. And then when I did the work on peer-to-peer currencies, yeah, I looked at file sharing. That was my domain. I didn't have the vision to take it to the next level. In fact, everybody was counseling me not to work on that topic in general. And the reason for this is simple. 2002, like think back to that time, the whole world was reeling from the attacks on 9/11. The whole world was fixated on payments to terrorists. So my mentors at the time came to me and said, "Look, you're doing some cool work. It is really exciting from a technical perspective, but as a young professor, you'll never find funding for this. So stop doing this because it ain't gonna. You're not gonna be able to make a good career out of it because the funding agencies will simply, in this current environment, will simply not fund this style of work." So when Satoshi came in 2009, he was right after the 2008 crash. The zeitgeist was different. People's concerns had shifted away from, 9/11 was becoming more of a memory by then, and they were really fixated on the worldwide crash. They were very, very concerned about the expected inflation to come shortly after all of that quantitative easing that was going on. And so there were very different concerns. And Satoshi had a vision far greater than anyone who came before him, which was to build a new store of value for the digital age, a coin that's in limited supply that you can easily transfer around the world, and for which there is nobody in charge. So that was his vision. It's a fantastic vision, and so don't get me wrong. Yes, I've found issues with Bitcoin, etc. I've proven that certain things that Satoshi thought about his system were not exactly correct. But at the end of it all, he had an amazing vision and an amazing technical achievement. So no one can take that away from him. It's been fantastic. So that's where we are now. We rise on his shoulders.
Yeah, no, that's all really interesting, sort of how that emerged with everyone in their silos, and this sort of comes out of the blue, and it has this grand vision. Fast forwarding to today, obviously we'll spend a lot of time talking about Avalanche, but from a more global sort of crypto perspective, is your vision of the future that there's going to be, one or two or a few useful and like power law popular blockchains, or do you think there's going to be one to dominate, or that like Bitcoin might be useful for store of value, but people aren't going to be building stuff on Bitcoin? That's where Avalanche comes in. How do you think about the sort of end game for cryptocurrencies and blockchains?
Yeah, so that's actually fairly straightforward. In all of these cases, the popularity of platforms follows some kind of a power law distribution. So there's typically a big leader, there's typically a second follower, and then there's a long tail of contenders, but there isn't really that much of the market left for them. The network effects are such that people want to congregate around those most versatile, most scalable platforms that can absorb the growth that is to come. So we are nowhere near the end game. We are in the initial opening salvos. People are placing their chits on the table, and you see different people making different moves. Bitcoin is playing for the store of value area. It is not trying to be a scalable platform. The Bitcoin developers they've never wanted to support any asset other than Bitcoin itself. So people are using Bitcoin now for ordinals, runes, inscriptions, etc. But really, that community is focused on BTC as a store of value. And so that's great. Moving forward, I think about 10 years from now, we're going to find that Bitcoin's security budget through halvenings is going down. And at some point, it will make sense to try to move Bitcoin to a different foundation. And we might also find that the amount of money that it pays to miners is a limiting factor in its growth. And we might also find that there are changes made at the protocol level. What I think we might really find is that Bitcoin will either become an Avalanche subnet, or will have to adopt ideas from the Avalanche protocol to patch up security. That's what I see on that front. When it comes to smart contract platforms, I think it's very clear. We had a spate of protocols that came in and tried to do the same thing faster and faster. You had Ethereum, which was an initial attempt at this, very general, it kind of works okay. But it's a single chain. It supports multiple assets, very different from Bitcoin. You can create your asset on Ethereum, and that's fantastic. But there's only one chain. And if you come up with something that's really popular, it competes with whatever I might want to do. We share the same block space. Solana is the same idea done by a different set of engineers who are far more performance minded. And they cut all the corners you could to make things go fast on a good sunny day. And the issue with that is there are days when things aren't as sunny and happy as you want them to be. You might have a validator fail, you might have two successive validators fail, and that typically starts a cascade. Because you cut all these corners, you don't have any headroom, and then suddenly the whole thing comes down. But regardless, maybe, whatever, maybe that can be patched, maybe that can be improved. But at the end of the day, it's still the same architecture, single chain, multiple assets, just like Ethereum. So when you have that architecture, you're fundamentally limited by how much you can scale. So you're going to be limited in the number of concurrent activities you can support on a single chain. Avalanche is the third wave of, and the final wave of blockchains. It has a very different architecture. It's not just a single chain. It's a chain that actually supports the creation of many other chains that are independent from each other, that are parallel, that can have their own rule sets. So the growth of our system is unlimited. It's uncapped. There is no capacity limit to what we're building. And this is a very different take for which we came under a lot of attack. It also makes our system more complex than others. So it's a little harder to evolve to build Avalanche than it is to build Solana. It's a little harder to build Avalanche than it is to build and change Ethereum. Single chain systems are always going to be simpler than a system like Avalanche. So you are seeing exactly what we expected, that it takes a little bit more time for Avalanche to find its footing, for Avalanche to evolve, but its growth is uncapped as compared to these single chain systems where there's a hard performance cap on what the underlying platform can do.
Yeah. So a couple of questions there. First, I guess as you talk about its, abilities being sort of, or its scale being uncapped, if you're talking about a system that handles scale with ease, versus a number of other competing systems that have challenges with scale. Even, you look at Ethereum and they've made like tremendous progress in the last few years. But that progress has to sort of go hand in hand along with its popularity. And if one gets ahead of the other, there's like that constant, that race, as Ethereum becomes more and more popular and used by more and more people for more and more transactions. Why is it that Avalanche actually benefits from, this increased adoption? Like if you look at crypto as a whole pie, right?
Mhm.
Regardless of, which project you're in favor of or which ones you think are best, I think most people can agree that the pie has been and is getting larger. It might not be over, you look year over year necessarily, but every 4 or 5 years, over every 4 or 5 years, it's just getting bigger and bigger in a huge way. And as that happens, even if the various slices of the pie are taking different slices of the overall crypto market, all of them are basically growing, all of the big ones that aren't falling out of favor or dying completely. How does that just growth of the industry and the market as a whole benefit AVAX relative to, or benefit Avalanche relative to other projects where they may have difficulty keeping up?
Sure. So that's exactly the question that was motivating us. How do we build a system that, with growth, it will be able to absorb the growth that we expect to come into the blockchain space? And the immediate answer was, if you build a single chain system, you will forever be limited by the max capacity of a single chain, and you will forever end up putting different disparate activities onto the same chain. What do I mean by that? Well, on Ethereum, NFTs and NFT transactions compete for, let's say, a game that might be using Ethereum that day that's popular. And they compete with DeFi transactions. Somebody trying to post collateral for their loan is often trying to compete with other people who are using that chain for other purposes. And that's why you see these enormous fee spikes. That's why you see these people paying multiple hundreds of dollars on occasion for transactions that are crucial to them. So, so single chain systems will always have that limitation. In contrast, we designed Avalanche to have and support what we call these things called subnets. So what it is, a subnet is simply a separate, independent, sovereign blockchain. So Avalanche out of the box comes with 3 different chains by itself. And to date, I think there have been more than 100 or so major chains launched on top of us. So what does that mean? It means that you and I can start a specific chain for our application. Suppose we have an application that involves Internet of Things. We're going to connect a whole bunch of embedded devices. Or suppose we have an application that's a DeFi application that we worked on with, let's say, partners from Wall Street right behind me. And we ended up doing a complicated system that requires compliance with American laws. Well, then we can start a chain where the validators are all located in the US, where it supports, for example, access by everybody except the people that the U.S. has banned, has sanctioned. Suppose that you and I want to run a chain that's really, really fast to support a really demanding game, where we don't want the fees to spike when somebody else is issuing an NFT mint. So how do you do all that stuff? Well, with Avalanche, it's trivial, because with Avalanche, you can start a dedicated chain for each and every one of these use cases. Because those chains are independent of each other, a load spike on one or a fee spike on one of them doesn't impact at all any of the other chains. And that's a really strong position to be in. This is in contrast with the prevailing thoughts at the time that we launched. At the time when we launched, people were like, no, you don't want this. You want shared security, which essentially means the validator set for the chains is all shared by all of the chains on top of them. If you do that, you end up being limited by the hardware capacity of the sum total of your validators. Whereas if you do it the Avalanche way, which is where all the chains are independent and sovereign from each other, where they don't have to share validators, well, then you and I can start a chain for our game that is populated by really beefy, really expensive validators. Maybe we don't need as many of them, but maybe we want them to be really fast. And our chain can go at a speed that's far faster than a chain that's more decentralized, that has more modest hardware in it. And the Avalanche architecture enables this to happen. There are only two other chains that share this architecture. One of them is Cosmos, the other one is Polkadot. So Avalanche is part of the latest wave of chains, and it shares with Polkadot and Cosmos this notion of having multiple chains together. But Polkadot has the shared security idea that limits its performance, and Cosmos has a centralized hub, and Avalanche doesn't have any of those. So there are a bunch of things at the sort of second level that make Avalanche not only able to absorb growth, but also it doesn't have any centralized components through which you have to communicate. So what does that mean in general? It means that the system is versatile. You can start your own virtual machine of any kind. We're not limited to the Ethereum virtual machine. You can use the Move virtual machine and so on. And what else does it mean? It means that the system can be compliant, and it means that the system can be fast and scalable. So that makes us very, very different from our competitors.
Right. So if I'm sort of understanding correctly, I'm thinking about these different subnets or these different blockchains, and they're somewhat configurable. Like you said, like there's one of them you might be creating to build a game on top of, another one might be for DeFi, another one might be like a pure store of value. Or let's use three examples that are a little more differentiated, like a store of value / DeFi, like something very financial versus something more social media focused versus a game.
Perfect.
And in order the sort of money related blockchain, the financial store of value, sort of that one, you're going to want like maximum decentralization. You're going to want something on the order of like a Bitcoin or an Ethereum. And you're willing to trade, speed and cost and things like this. And then on a social media, it's also important. Like you don't want censorship of who can join or say what or whatever, but it's like not that important. And then a game is like the least important. Like there might be some reasons why it's useful to have some degree of decentralization, but it's like not as critical. So do you have to then, as a user, like joining in on these various applications built on top of these different blockchains or subnets, do you have to sort of evaluate each one by one, or can you sort of rest easy knowing that there are some similarities between all of these subnets because they're a part of the Avalanche sort of ecosystem, that there's certain things you can trust are sort of givens for all of them across, regardless of the configurations?
So the most important thing from the user's perspective is to be able to seamlessly jump between these chains. You should not have to incur a cognitive cost. Which chain am I on? Which chain should I be on? Where is my liquidity? How do I go from here to there, etc.? So the users care foremost about that user experience. And for that purpose, we have this thing called a core wallet, which makes all of these chains seem seamless to the user, coupled with a technological component that we call teleporter, which allows any chain to send a message to any chain. So from the user's perspective, it ought to be the case that these chains are connected together. They act as one, even though you might be using one or more of them actually at any one time. For example, you didn't mention this, but we have a very aggressive, very interesting DEX that straddles two chains. It stores the assets on one chain where it's secured. It stores the assets on what we call our C chain, on the DeFi chain. So it stores the DeFi assets on one chain, but it performs the trades on another chain. So that second chain, the load is isolated, so you can perform a lot of trades, and therefore the maximum capacity is very high, and the fees are very low because it's not sharing the DeFi chain for its DEX operations. But the user never gets to see any of this. As far as the user is concerned, they just move their assets, they go to the website, they interact with it as usual. Now, it's always going to be, to respond to the second half of your question, it's always going to be the case that these chains need to be evaluated by the user. The security they provide is determined by the set of validators that form that chain. So before you use a chain, let's say a game chain, you should be evaluating it to see if it's truly decentralized. What level of decentralization does it provide? You should be doing this anyway. There are a lot of L2s today, for example, that are fully centralized. In fact, as far as I can tell, almost all L2s are fully centralized entities. People shouldn't be using them. They're trash. You're just running on someone's laptop. You're getting performance because it's on a laptop. You're getting low fees because it's on a laptop. You're not paying the cost that a truly decentralized system needs to pay for decentralization. That's how they eke out that. And despite giving up on the most important thing for crypto, they manage not to get that much performance. So Avalanche is unique in that it has this nice architecture and it has a fast consensus protocol that allows these costs to be high, to be low, that allows the performance to be high, despite the fact that there is extreme decentralization underneath.
Yeah, one thing that's kind of interesting about what you just said, I think about this a decent amount that people have different sort of preferences from what they might say that they prefer. And with crypto, like, it's claims to be all about decentralization. But in reality, for a lot of people, it's about making money or being a part of something new and interesting or whatever else, whatever thing, or, being able to be a creator and participate in the digital economy, whatever it might be. And so I wonder about this, and I wonder what your thoughts are on where decentralization is actually most critical and important versus where it's a nice to have that it actually doesn't really matter, or are we just trying to build a system that is based on principles of decentralization so that even the things that don't require decentralization should eventually be sort of a part of that system at sort of the outer layers?
So I think you earlier gave three examples, and you did a beautiful job of enunciating when you need decentralization. So for financial high-value applications, you definitely want decentralization. You certainly don't want capture by intermediaries. You certainly don't want to be played by the likes of Citadels of the world, by the likes of HFT people in the world who can jump in between you and your trade, right? So you definitely don't want systems that are closed, where some incumbent sits between you and your operation, your transaction, and collects a fee from you. So for high value assets, you definitely want a decentralized platform. And that's what we set out to provide with one of our default networks. It's called the C chain. It's extremely decentralized, huge numbers of validators, and it's incredibly fast by virtue of its consensus protocol, despite the presence of large numbers of validators. So you want decentralization when there's high value at stake. You might want to give up on decentralization for things like games, right? If my games, I typically don't put any money into them. I just play them opportunistically as long as they amuse me. There's nothing I care about on there, except my time that's invested, I guess. And it's okay. I want there to be, those machines have to be big, beefy machines. And I don't mind if there's a small number of them. It's okay. The thing that I care about in a game is auditability. I want people to be able to see what happened, and I want people to have some idea of being able to ensure that the game was played fairly by all participants. So that I care about that, but I might give up on decentralization while I achieve that. Do people care about decentralization themselves? Do they care only about making money? That's at the moment that might be true, but there will come a day of reckoning when a regulator comes in, looks at the scene and says, look, you know, these folks over here, they call this an L2, but it's really just 5 people controlling a multisig. It's really just one machine, a single machine. It's like it's literally the same as someone's laptop. There's a For most L2s out there, there's a single sequencer. And that single sequencer executes all transactions on that L2. And if you do that, you're in a very, very vulnerable situation from a regulatory standpoint. If there is an exchange on your L2, you're running the exchange, and you're running an exchange without any permits whatsoever. Now you can hope that the regulators are not sophisticated enough to see through your facade. You can hope that you're in a field that's really cutting edge. People don't understand it. You might hope and pray that you can mumbo jumbo your way through an explanation to a regulator and they'll let you pass. But I know, and all the techies know, that these centralized components are incredibly vulnerable from all sorts of perspectives. And not only just a regulatory attack perspective, also, if there's only a small number of validators, then those people are in a position to come between you and your transactions. They will front run you. They will extract MEV. They will come between you and your trade. They will sandwich you. They will front run you all day long until you bleed of money. So, you know, we are not in this space to reinvent Wall Street. I'm not in this space to reinvent what we have with more complexity around it. I'm in this space to build something entirely different, one that's democratic, one that's open, one that allows everybody to participate, not just another closed system with 5 people just skimming off of every transaction.
Right. When you talk about the regulatory risk, is the risk that's there, the regulation that it's, at conflict with one, you could take it for granted that, the regulation is worthwhile, but is it actually? Is there a good reason why the regulations that those L2s may or may not be, crossing paths with? Is there a reason that regulation is necessary? Because, obviously
That's a
there's a lot
great
of
question.
regulation that's not.
That's a great question. So let's talk about that. So um, there are a bunch of regulations, right? So you can't throw a stone. You can't even give things away easily without without hitting some regulatory boundary of or another. When it comes to finance, I think there are 57 different federal entities in the United States alone that might be involved. So we certainly have overregulation. What do I personally think about weaponizing the financial system? What do I personally think about putting a regulatory burden on people? I think it's abhorrent. I don't think we should be trying to use the financial system to try to limit people's activities. Imagine where our society would be if you went to every corner store, every bodega in New York, and you said, you can't sell a packet of gum to someone who is on the following lists.
Hmm.
So therefore, every bodega user would have to show up with an ID before they can buy just a packet of gum from that fellow. There'd be no life on earth. Like you just wouldn't be able to function as a society because everybody has to vet each other. Before you talk, a telecommunications provider, for example, the internet would not be here if we did not provide some kind of immunity to telecom providers. If you went to every phone company and said, you can connect anybody you like, but make sure you never connect a terrorist or the following people on these lists with anyone else. If you put that burden on that sector, you will crush and kill that sector. So what do I think about this? So I don't think we should be doing this. This is not a good thing to be doing. And in fact, principally, it's just a bad idea. Now, there is a reality. Societies have their laws for a reason, and the laws act as an immune system of sorts. And I can see why or how, on occasion, on very limited occasions, it might make sense to say the following large companies or large corporations should not be able to participate in our economy. I understand that. I think we as a society should be able to say, look, we're being threatened with nuclear weapons by North Korea. We don't want North Korean, government to be able to connect to our system. We don't want North Korean banks to be able to connect to our system. I think there is some judgment to be applied here. So I am not one of those people who says all regulation is bad, but I think I'm a regular pragmatic person. I can see why societies might say, look, these folks are our enemies at the moment, and we have to put some barriers. So now, I think what needs to happen is that we have to provide, as platform providers, we have to provide the tools for selective, reasonable enforcement, and I can't wait for that to happen.
Yeah, it's interesting. This is I hesitate to switch gears so much, but I just thought of it because I know that you were very interested in like artificial intelligence going back to high school and thinking about autonomous agents even back then and things like this. And I've heard you speak about how you're concerned about bias in like LLMs and other sort of emerging AI at large. And I'm curious with regulation, like those two things seem to sort of go hand in hand, where I think about, you can have no regulation or you can try to, carve out North Korea, but it's like, then where do you draw the line? If you ban North Korea, it's no longer black and white, it's gray. And where do you draw the line in the gray? And with AI, it's kind of similar. You have people advocating for completely free speech or things like this. And then you have people who draw the line on, certain, levels of violence or whatever it might be. And then it's like, well, next thing you know, that line in the sand comes all the way to where you can't get a fair read on like different people running for president and their thoughts and things like this. So, um, it's interesting. Do you give sympathy, I guess, to this idea that you actually do need to go black and white and in both cases really towards like decentralization and the inability to sort of regulate because you just can't if you draw the gray line, even though it's very reasonable and pragmatic to say, we don't want North Korea. Like you take the extreme example in either case, and it's very reasonable to say we don't want them involved or participating, but that brings in this, higher level problem of having to find where the line is, which is like extraordinarily complex.
I fully agree with you. Drawing that line is so insanely difficult. And we've seen regulation used by the incumbents to establish a moat. We've seen people try to use regulation to kill off competition, to kill off technological competition, to kill off new innovative developments. And crypto has faced this from banks repeatedly. We've had all sorts of issues, as I think your audience knows very, very well. So I agree with you that the slippery slope argument is a strong one, and you can slide all the way to censorship, to lists of people we like and we don't like, and typically what ends up happening is regulatory capture by incumbents, and that's a very common scenario. But I cannot, just as a person, and as a pragmatic technologist, I cannot flip and simply say all regulation is bad. Let's keep it black and white, no regulations at all. That's just not me, and that's not the world either. So you leave people alone. Something like 9/11 happens, and they want to just suddenly give up whatever they were doing. They want to give up their freedoms, and they want to start putting in fences. And as I mentioned, North Korea is an extreme situation. I think it's pretty clear what we should be doing there, and so that's the reality that we live in. And so we face a choice as platform developers. Do we come at it from an ideological perspective, from an extreme libertarian angle, where we say, look, we're going to build a fully decentralized platform. It obeys nobody's laws. It does what it wants. And the world will have to adopt to this. We'll just have to build and it will just have to deal with these platforms. Or do we build the kinds of platforms that give people the ability to launch blockchains that are compliant with a particular area's laws? That's really the big question. And Bitcoin, for example, takes the former approach. And Bitcoiners, you're going to hear are going to be very, very libertarian folks. They're going to be like, no rules, no laws, down with the US dollar, up with Bitcoin. That's what they would say. With Avalanche, we take a different approach. We're philosophically different folks. We are essentially saying, look, we would love that environment, a no regulation environment. We would love a world where enforcement is done by enforcement people and finance is done by finance people, and finance is not used for enforcement. That's just, you don't push that burden onto regular people who want to send value around. Like that's where we lie. But given where we are today, let's provide the tools for people who have valuable assets who want to then support them in a blockchain environment. So we can do things with our architecture that Bitcoin cannot do. I can build, for example, and we have built networks of blockchains for Wall Street companies, for collections and consortiums of Wall Street companies that want to trade among each other, and they want to make sure that no North Korean is on the other side of a trade. This is a need they have. If you don't meet this need, then they won't be able to use your system. And Bitcoin can't meet this need, but Avalanche can. And we created for them essentially a walled garden, and the wall essentially keeps out, at least in the online version, all of the sanctioned countries. So that's, I think, our big philosophical difference. You put your finger right on the issue. We are philosophically different. We are pragmatic, and we want to allow people to build whatever they might want to do. I know where I stand. I hope society will come to where we are. But until then, I want my system to be adopted.
Right. So one more question coming back to like the architecture of Avalanche, and you talk about, you know, the C chain being like the most decentralized, and I'm wondering like and maybe you can sort of introduce the what I think was like the key innovation that you alluded to earlier, like sort of the third wave, where you have I think this is what you're referring to, at least, where you had sort of classical consensus and then Nakamoto consensus, and then Avalanche came to the picture with a different idea. And I'm curious, how much did that innovation, without this sort of multi-chain subnet, you know, addition to the vision, with just that on a single chain, was that sufficient to some level, or to what level was that sufficient to enable, you know, larger amounts of scalability without sacrificing speed and cost and security?
Great question. Thank you for bringing that up. I didn't focus on the consensus protocol behind Avalanche when I first talked about it, and let me go into it in a little bit more depth. So my expertise area is distributed systems. It's not an area that's been around for thousands of years. Obviously, it's only been around for 70 years, like 60 years. In that time frame, people very early on in the late 60s, they realized that it's essential to have multiple computers coordinate among each other. You want to have multiple machines just in case one of them crashes or is taken out by an attack or what have you. You want to have multiple machines act in tandem. That you want all of them to share the same database. This seems like an easy problem. It's not an easy problem at all. It's called the consensus problem. And you and I and you know the 10,000 to 100,000 other people we know, suppose we wanted to maintain a database, you need to somehow coordinate updates to this database, right? Jake gave Gun 5 AVAX, Gun gave 3 of those AVAX to John, etc. You need to maintain an orderly ledger with a large collection of nodes. This is known as the consensus problem. Some of the nodes might be what we call Byzantine. They might misbehave. So building protocols that maintain an orderly database in such a setting is a hard problem. And there were only 2 approaches to building such protocols. There is, in the 60s, academics identified this as a big issue. In the 70s, we began to see some solutions to the consensus problem. And in the 80s and 90s, they got a bit more fleshed out. And so academics had been working on this problem for a fair amount of time. And they came up with protocols where essentially they're voting protocols. You have a set of validators. You can think of it kind of like the Senate. You have a set of validators, and that accepting a transaction is kind of like passing a bill through the Senate. So you need to make sure that a supermajority of the senators have signed off on this transaction. So, you know, Alice wants to give Bob 5 coins. Is this okay? And then people just say yes or no. and there's a tally. So these classical consensus protocols all involve all-to-all communication among the validators. Solana needs this. Ethereum needs this. They have all-to-all communication. What does that mean? Well, it means that if there are 100 people, they have to check signatures from 99 other people. So it's in the square of the validators. So what does that mean? Well, square grows really fast. If you have 100 validators, so there are 10,000 messages going around 100 square. If you have 1,000 validators, you've got 1,000,000 messages. It begins to get a little expensive. If you have 1,000,000 validators, none of those protocols would work, right? Why wouldn't it work? Because 1,000,000 squared is a very large number. Right? So can't have 1,000,000,000,000 messages going around the internet. It's just going to end up clogging everything. Okay, so then what does Avalanche? So that's that. What does Bitcoin do? Satoshi was brilliant the way he did the consensus along with that minting. He ended up coming up with this proof of work idea where the consensus protocol is essentially run by a miner, and every 10 minutes the miner announces the blocks that he found. But it has its own scale limitation. You can't really speed up Bitcoin anymore. It's the block interval is 10 minutes and it's fixed. And if you try to make it go faster, or if you try to make the blocks bigger, then it wouldn't scale. The certain miners, a cabal of miners, would be in a privileged position. The person who found the last block would always be in a privileged position if you try to parameterize it to make it go faster. Avalanche came into the scene, and it was a huge breakthrough. And in the space of distributed systems, I would say that Avalanche is the biggest breakthrough in distributed systems in the last 10 years. Why is it such a big breakthrough? Because it showed the world that you could do consensus without having all of your senators communicate with all the other senators. How does that work, you might ask? I can give you the quick rundown. It's very, very simple. Imagine that you have a Senate with 1,000,000 people in it, 1,000,000 senators. If every one of them tried to collect a signature from every other, it'd be just such a mess. It'd be undoable. But it turns out that if each of the senators did the following thing that I'm about to outline repeatedly, it turns out they would quickly come to a decision. What is that thing? Instead of contacting everybody in the Senate, they just pick some number of people. They pick their 10 best friends and say, yo, I see a transaction from Alice to Bob. Are you inclined to accept this or not? So you ask 10 people, and those 10 people ask their 10 friends, who ask their 10 friends, and so on. And that quickly reaches out to everybody in your Senate, even if it has 1,000,000 people in it. So I don't have to personally check with everybody. I check with enough people who check with enough people who check with enough people that there is consensus around this transaction. That's the magic, that's the insight that powers the Avalanche consensus protocol, that makes it scientifically so much faster, what we call asymptotically so much faster at reaching consensus than other protocols. So that was the big breakthrough. And so that was the thing that caused me to say, whoa, this is really, really fundamentally different than anything that came before. And this is worth leaving behind my academic career and turning into something really big, because it is actually something fundamentally different and some fundamentally faster than everybody else's approach.
Right. And so it's clear, based on all of this, you have a ton of confidence in the way that you've built Avalanche. And, earlier we were talking about Bitcoin, and you were, alluding to a future in which maybe Bitcoin could even be a subnet on Avalanche. And this is like a level of confidence and conviction that's fairly rare to find, especially in like such a large game as crypto is. And I think, as far as I can tell, that sort of stems from like your conviction in the success of Avalanche is really rooted in your conviction in the superiority of the technology. And so the question that I'm wondering about, that I've sort of thought about in other contexts in the past, is despite or regardless of conviction in the technology, does that necessarily translate to the success of the project? Can it be the case that timing or marketing are actually reasonably heavily weighted variables in the sort of overall equation of success? Is that something that you think about?
Absolutely. Such a great question. So this is something I think about all the time, right? We are technologically superior, and but history is full of cases where, yes, you were superior in some fashion or another, but somehow those projects failed anyway, right? Everybody knows Betamax versus VHS. There are many other examples. If you're mostly the same, but you're like 10% better or 50% better, well, then other factors will come into play. So I think about this all the time. Yes, we're technologically head and shoulders above everyone else in terms of technology. But where are we in regard to other things? So I don't think you can succeed in this game without a strong community. I'm really proud of what we've built with Avalanche. It's really diverse. It spans all the continents, including the Antarctica these days. So it spans a whole lot of different economies. It spans a user base so broad that I think we have now achieved escape velocity, where we are, I think, on a very good footing across the world. Like I go to Korea, people recognize me there. Go to Japan, I go to wherever in the US, people recognize me. So we've reached the point where people understand what Avalanche is, that it's one of the top few chains, and definitely the up and coming chain. So community is key, but you can't just win with that alone either. You got to have technology, you got to have community. You also have to have an organized set of people across your community who are pushing your technology with you, for you, etc. As a user. When I say you, I mean a user here. So in our case, I know that the Avalanche technology is being adopted by players on Wall Street. I know that there are people across the entire world who are building Avalanche into their products. In Korea, the biggest company, SK Planet, is using it for their user base of 35 million people. That's like half of Korea. Korea is only 80 million people. So 35 million users are using a subnet on Avalanche for their loyalty points. And that's a thriving, and there are days when that subnet does more transactions per day than Ethereum. That's just our loyalty subnet. It's just one of many. There are people in Japan deploying this thing. So you gotta have people using your system. You can't be a directed, it's like you can't be a blockchain for games. You can't be a niche play in this space. We've always paid attention to covering all of our bases and ensuring that the offering we have, the technological offering we have, can be used by a large number of people. So I'm very happy with where we are. So let me also share something with you that I haven't really mentioned anywhere. I was recently at ETH Denver, and I went there with some trepidation. I went there thinking, Ethereum community is a lot bigger. People have heard, everybody's heard of Ethereum. Everybody knows Vitalik. So we're not there yet, right? So I'm going to go to ETH Denver, and I might encounter a community that's much bigger than mine, which it for sure is, right? We are still very early at Avalanche. So this community is much bigger than mine. And also, they might be so far more advanced than us. They have had 6 extra years to think through a lot of problems. I wonder and I worry that they might be far deeper into issues than we are. And that was a real concern for me. Like, I could find out that we are just lagging behind, that these people, like, there are advantages that they might have that I just can't chip into. But I went there, and my discovery there was very simple. They ended up adopting a worldview that was flawed in some subtle ways at its core. And now they find themselves in this universe where they have a single chain. That chain is limited in its capacity. And the only way to break through is this L2 vision. That is, they expect people to build chains rooted on Ethereum. Well, all of those chains are cannibalistic. All of those chains are in competition with each other. None of them have any incentives to work well together. They're all dividing the liquidity up. And if you go there, ETH Denver was full of what I would call trash L2s, just a bunch of centralized operations. It's just Jimbo's laptop running an L2, running Geth on a single machine, and if that's my competition, then Avalanche is far more advanced. And I came away from that whole meeting thinking, oh my God, I really built this up in my head to be a real hard competitor. but it's not like they're going the wrong way and they can't even reverse course from this point on. They're just committed to the L2 vision, and there is no backing out of it for them. And and at the end of that vision lies this very asinine game of people creating more and more L2s, and the more of them you have, the worse it is for Ethereum. So that's what I think. Do I worry that incumbents are going to be forever untouchable? No, not at all. Do I worry that somebody is way ahead of us? No, absolutely not. The L2 vision is bunk. I've called it. I called it out to Vitalik the day he mentioned it, and I think the world will come to see that as we move forward. So again, going back to the initial thing I said, the advantages you bring to the table have to be orders of magnitude better. So if you're 10x or 100x faster or 1000x faster, if you are unlimited more scalable as opposed to 100x more scalable, if you're like unlimitedly more scalable than any of these single chain systems, you're in a different ballgame. So, but let's be clear, there are disadvantages to the game we are playing as well. And the main disadvantage is Avalanche is a more complex system. It's not going to be, and launching new chains is a slow process. So these new subnets that are coming online, these new AAA games that are coming online on top of Avalanche, they take time to build. So our success is not going to be overnight. So it's not going to be like, oh yeah, tomorrow we're like suddenly, no, it's not. It's going to be, we'll have to wait for a whole bunch of new chains to come and flourish on top of us. And as that happens, I think people will realize, okay, this multiple chains acting as one is where we all needed to be in the first place. So that's the world we're building for.
Well, look, I appreciate all of this vision and perspective and appreciate taking the time. I know we're up on time and I want to be respectful of yours, but before we let you go, where can people who are interested based on this conversation and learning more about Avalanche and getting involved, where's the best place for them to go and do so or to follow you moving forward?
Sure. They can go to let's see, like they can start at avox.network. That's a good place to start. They can go to the subreddit, which is reddit.com/r/avax. They can also follow me on Twitter, Elite Hacksaw, except it's spelled funny, EL33TH4XOR. So it's like a name from the good old hacker days a long, long time ago. And or just do a search for Avalanche Crypto or what have you, and you'll come to our pages. But it's been so much fun chatting with you. Thank you for having me here, and I hope we covered enough of the core space that people realize that we are doing something fundamentally different compared to other people in crypto. And come and join our community. It's so fun.
Awesome. Well, fascinating conversation. Really appreciate it again. And I certainly have learned a lot in preparing for this and now having the conversation with you as the cherry on top. So I appreciate the time and look forward to keeping in touch.
Thank you so much, Jake.